All right, here we go. Chapter 1, Section 4, Graphing Motion. Our vocabulary preview. We've got acceleration, which is the change in velocity with respect to time. We've got vector, which is magnitude and direction, which we saw in the previous sections. Negative acceleration is acceleration associated with velocity, that is getting closer to negative velocities. Positive acceleration is acceleration associated with velocity that is getting closer to positive velocities. Remember that velocity is a vector, so we can have positive and negative velocities, just depending on the direction. We have a tangent line, which is a straight line that just touches a line, especially a curve. Our what do you think question is here. Hopefully you've answered it already before doing the investigate. Very important step, addressing what we think we know about the world. Some differences and similarities between a car and a bus stopped at a traffic light, and then they're speeding up. What are some differences and similarities? In this investigate, we were rolling the cart down the ramp, and we hopefully saw that as the cart starts out, it's kind of going, and then it starts speeding up a lot faster towards the bottom of it. And that's the whole idea. That is an object accelerating. We used our motion detectors to look at position versus time graphs for these, and we saw that if we look at our graph, if this is a position versus time, then we saw something that kind of looked like this, right? And this shows that our velocity, which remember is our slope of this line. Slope is rise over run. And if we have a change in x over a change in t, then that's going to give us our velocity. Look at that, I did that all with straight lines. How about that? All right, so here the instructions had us looking at the tangent line. And remember that tangent line is the line that just barely touches one point. And the idea here is to see how does the steepness of this tangent line change. Well, that's just a bad line in general. Okay, so we see that in the first segment, the first tangent line, it's increasing. So our velocity is happening. Our position is increasing. We're speeding up a little bit. Now we're speeding up a lot. Our velocity is changing every instant that goes by more and more and more. And then by the third second, our velocity is changing very rapidly. Galileo used an inclined plane to slow down gravity. It was initially thought that if you take a heavy object and a lighter object and you drop them at the same time, that they're going to fall at different speeds, because the heavy object had this inherent want to return to the Earth more than the lighter object. We know better than that now. But Galileo wanted to know more of what was happening as things fell. Remember, he famously leaned out of the Tower of Pisa. Same guy. Dropped the two round objects. So, to slow down gravity, here is an object in free fall where it's just falling. Remember, this is a strobe photo, so the ball is shown every second the camera was going by. You could think of it like that. I'm sure it was less than every second, but an equal time interval. Here, there's not a big difference in between the two shots, so we know that the speed is not very fast, and by the end we have a much greater increase in the distance that was covered in the same amount of time. So it must be moving faster. So what Galileo did was he took something and put a ramp in between it and the Earth. And what that does is it allowed him to work with this acceleration due to gravity in slow motion. And this is in a time before cell phones, before cameras and all of that. So by using this ramp, he was able to see what was actually happening with acceleration in general. Remember, with vectors, direction matters. If your gas pedal, which is officially called the accelerator pedal, because it causes your velocity to increase or accelerate. If you are moving forward, you're moving in the positive direction. If you're moving backward, in the negative direction. If you're moving forward on a road and you press the accelerator, you're going to have a positive acceleration because our velocity is getting more positive. If we start out at, let's say, 2 meters per second and we put the accelerator forward, then we're going to go this way faster. So we would say you have a positive acceleration. If you're going backwards and you have a velocity that is moving backwards, more towards negative numbers, out of my way. So you have, and you press your accelerator, you're going to have a velocity that is moving even faster in the negative direction. So it's moving that way even quicker, more towards big negative numbers. Like past -5, -10, -20. Velocity is getting more negative, so you have a negative acceleration. If velocity is getting more positive, then you have a positive acceleration. Here's another one. If you're moving forward on a road and you press the brake, you're going to have a negative acceleration. Because, let's say our velocity starts at 5 and we press the brake. Well, that's going to slow our velocity down to 0. So our velocity is getting closer to the negative numbers, so we have a negative acceleration. This is kind of tricky. Is it positive? Is it negative? I think that having you think about it on a number line, am I getting more positive or am I getting more negative with my speed, then that tells me my acceleration. I think that will help you when it comes time to be assessed on this, whether through an exit ticket or a test or quiz or whatever. Here's the last one. If you're moving backwards and you press your brake, so you're backing out of the driveway and you press your brake, what are you doing? So let's say we have a negative velocity of -4 because we're going backwards. We press our brake, then we're going to be slowing down, right? So our velocity is getting closer to 0 or closer to the positive numbers because when our velocity is 0, we're stopped. So if we press the brake, we're slowing down until we get to 0. So that means we have a positive acceleration. We'll deal with this in the next video.